Hello, Mr. Betts here. I want to take a look at a few examples of alternating series and talk about whether or not we can use the alternating series test to see if the series converges or diverges. So we'll just take these one at a time here. Remember, there's three conditions that have to be met to use the alternating series test. I actually like to check the third of those three conditions first because that one is the nth term test for divergence. So the first condition, sorry, let me change that. The third condition is that the limit of the terms as n approaches infinity, and I'm just going to use a sub n here. So the limit of the terms here is 0. In this case, it doesn't matter if we're looking at positive terms or negative terms. So I'm just going to look at the limit of 1 over 1 plus the square root of n. If this is not 0, then the nth term test for divergence says that the series diverges and we're done. If it is 0, then we can move on and see if the alternating series test is going to converge. So in this particular case, since n is approaching infinity, that means that the denominator is approaching infinity, and if we have 1 divided by a really big number, we're going to get 0. So the third condition is met, which means that the series could converge. We don't know whether or not it converges. If that was not 0, then we would know that it diverges. So the first condition, I'm going to go to that one now, is essentially that it's an alternating series. You don't really have to do anything to show it's an alternating series, but you want to convince yourself that it is. So if we look at this here, this has the telltale sign of an alternating series. It has that negative 1 to the nth power. So that is going to alternate between positive 1 and negative 1. And just to confirm, the denominator here is always going to be positive. So we always have a positive 1 over a positive number and then a negative 1 over a positive number. So this is an alternating series. So I'm just going to write alt and put a check there, just to confirm that it's an alternating series. The last condition is the least straightforward to confirm, and that is that for the absolute series, that any term is smaller than the next term. So what I want to do here is I'm going to look at u sub n. So remember, u is what I used for the absolute terms. So look at u sub n, and I have this backwards here. Each term is supposed to be bigger than the term after it to show that it's decreasing. So what I'm going to do is I'm actually going to look at these two things here. So u sub n is going to be 1 over 1 plus the square root of n. And I want to compare that to 1 over 1 plus the square root of n plus 1. Now, for us to be able to use the alternating series test, this here should be smaller than this here. For this particular one, it's pretty straightforward. What we need to keep in mind is when we divide by bigger numbers, we get smaller numbers. And it's pretty easy to confirm that 1 plus the square root of n plus 1 is bigger than that. And so since we have a larger denominator in the second one, then that's going to be a smaller term overall. So we have the third one confirmed. So having confirmed those three conditions, we can say that the alternating series so that's showing that condition 1 is met. We just know it's an alternating series, converges. We're doing the alternating series test right now, so it's kind of obvious that that's what we're using. But later on, when we're mixing all these tests together, we want to make sure that we explain why or what test we're using. So by the alternating, and I'm just going to abbreviate alternating, by the alternating series test, because so we need to put in our justification. We have the first condition, but we need to include the second and the third conditions. So we'll say the terms decrease in absolute value. I also use the phrase decrease in magnitude. Those mean the same things. So it just means that the absolute value of the terms is getting smaller. That's what we confirmed here. And then we also need to include that third condition. So we'll say to 0. So again, when we're using the alternating series test, we want to, one, say that we're using it. So that we're using the alternating series test, and we confirmed all 3 of the conditions that have to be true for the alternating series test to work. So in this example, I have the same example on here twice. So, okay. In this example, we're gonna go through the same process. So I'm gonna check the third condition first. So let's look at the limit as n approaches infinity of the absolute values of the terms. And for this one, we want to think about dominance or relative magnitudes of growth. And if you remember the exponentials and the factorials, between those two, factorials are going to grow faster, which means that this is actually going to grow to infinity. So this limit does not exist because it's going to grow infinitely big. And so right off the bat, we're not using the alternating series test. We're actually using the nth term test for divergence. So we're going to say the series diverges by the nth term test for divergence. So we never even got to using the alternating series test because that third condition was not true. And we know that since the limit doesn't approach 0, then the series is not going to converge. Okay, this last one here is kind of a tricky one. It looks like it's an alternating series. However, so that -1 to the n plus 1, that's that key indicator that we're looking for an alternating series. However, sine of n is sometimes going to be positive and it's sometimes going to be negative. And the oscillating nature of sine makes it seem like, well, that might make it an alternating series, but it's not going to be regular. Okay, so when n increases by 1, this is going to change from positive to negative or negative to positive. Sometimes this is positive, sometimes negative. It is somewhat predictable, but it's not going to match up with this right here. So it is not going to be an alternating series. So we can't use the alternating series test for convergence to do this. It actually turns out that the series is going to converge, but we can't use the alternating series test. So for this particular example, I'm just going to say the alternating series test is inconclusive. We can't use the alternating series test. So this is where we're going to have to take into account other tests. In this case, we could use a comparison test to show that this series is going to converge absolutely, but that's beyond the alternating series test, so we're not going to worry about that here.